let's take a look at this example. Many students get confused from where they're supposed to start. I recommend to redraw the circuit because we get used to keep the voltage source on the left side of the diagram and all resistors on the right side, at least at this level. Okay, and what we are going to do, we are going to redraw the circuit, and in order to do so, I'm going to find two reference points for point A and point B. This is not necessary to mark these points, but they're going to help us to redraw the circuit. Okay, so first I'm going to pull out the voltage source from the center of the diagram. Okay, I'm going to draw it on the left side of my diagram. So I have voltage source. Okay, voltage source is connected to 2 points, point A, and this is my point B. Please notice that resistor R1 is connected also to point A and point B. That's why I'm going to connect resistor R1 to point 1, to point A and point B. So I have R1. Next, please notice that these two resistors are in series, okay? Resistor R2 is connected to point A, so this is just the extension of my point A. Okay, this is my resistor R2. R2 is connected to R3, so I'm going to draw over here R3, and R3 is connected to point B. Okay, so the whole line over here represents point B. So if you are going to look at this diagram, this is a completely different story. This diagram, in my opinion, looks much easier than this one. So what we can do first, we have to find R total. We have all resistors given. So what I'm going to do, I'm going to combine these two resistors first. So I'm going to write R23 is equal R2 plus R3, where R2 is equal 4 kilo ohms plus R3, which is equal 6 kilo ohms. Everything together is equal 10 kilo ohms. Okay, so the total resistance of these two resistors is equal 10 kilo ohms. Okay, I can redraw the circuit one more time. And I have right now two resistors, R1 and resistor R23. In order to find the total resistance, I'm going to use the product over the sum formula. So I have R total is equal, in this case, R1 times R23 over R1 plus R23, where R1 is equal 15 kilo ohms and R23 is equal 10 kilo ohms over 15 kilo ohms plus 10 kilo ohms. This is equal 6 kilo ohms. Okay, so this is the total resistance of my circuit. So I found RT. Next, we're supposed to find I total. In order to find I total, I'm going to find first voltage across resistors R2, R3. Let me remind you, these two resistors are in series and the current which goes through resistor R2 is equal 5 milliamps. Because this is a series circuit, the same current will go through resistor R3. Okay, so we have current 5 milliamps which goes through the resistor R23 because these two resistors are represented by resistance R23, which is combination of these two. So V23 is equal I2 times R23. One more time. This current goes through these two resistors because they are in series. That's why I'm using Ohm's law to find the voltage across these two resistors. So if I2, which is equal 5 milliamps, times R23 we found is equal 10 kiloohms, this is equal 50 volts. Okay, so this is the value of my voltage source. And also voltage across resistors 2, 3, and this is also the voltage across resistor 1. Okay, and everything's equal 50 volts. Why? Because R1 is connected in parallel with the voltage source. That's why the value of the voltage will appear across resistor R1, and voltage source is going to also appear across resistor R23. That's why I wrote this statement over here, right? Next, we're supposed to find I total. I total is equal voltage source over R total, where voltage source is equal 50 volts over R total, which is equal 6 kiloohms. This is equal 8.33 milliamps. Okay, so this is the total current in my circuit. Next, we are going to find I1. I1 is the current which will go through resistor R1. So what I'm going to do, I'm going to simply divide the voltage which is across this resistor, and voltage across this resistor V1 is equal to the voltage source over the resistance of this resistor. So I have V1 over R1. This is equal, V1 is equal 50 volts over R1, which is equal 15 kiloohms. This is equal 3.33 milliamps. Okay, so this is the current which will go through resistor R1. Next, we're supposed to find the current which goes through the resistor R3. So I3 we said is equal to I2. This is equal 5 milliamps. Okay, one more time, these two resistors are in series, so the current which goes through resistor R2 is going to be equal to the current which goes through resistor R3. So we found I1 and we found I3. We found also voltage source and we found also V1. Okay, V1, if you want to find V2, V2 is equal I2 times R2, where I2 is equal 5 milliamps times R2, which is equal 4 kiloohms. This is equal 20 volts. Okay. Next, we're supposed to find V3. V3 is equal I3 times R3. So I have 5 milliamps times R3, which is equal 6 kiloohms, is equal 30 volts. If you want to verify your answer, you're supposed to simply add these two voltages together. And if you are going to add them up, you're supposed to end up with voltage source. Voltage source is equal V23. We can also say this is equal V2 plus V3, where V2 is equal 20 volts plus 30 volts is equal 50 volts. Okay, so if you are going to add these two voltages, right, voltage drops, you're supposed to end up with the voltage source. Voltage source is equal 50 volts, and we got 50 volts. It means that our calculations up to this moment are okay. So we found V2 and V3. Next, we're supposed to find total power. So if P total is equal I total times voltage source, where I total is equal 8.33 milliamps times voltage source, which is equal 50 volts. So P total is equal 416.5 milliwatts. Okay, so this is the total power in my circuit. Next, we're supposed to find the power at resistor R1. P1 is equal V1 raised to the second power over R1. V1 is equal 50 volts raised to the second power over R1, which is equal 15 kiloohms. So P1 is equal 167 milliwatts. Okay, so this is my power at resistor R1. Next, we're supposed to find P2. P2 is equal I2 raised to the second power times resistor R2. Let me just remind you that it doesn't matter which formula you are going to use. If you are going to use the formula with the voltage raised to the second power over resistance, or current raised to the second power times the resistance, your answers must be the same. So this is equal I2 5 milliamps raised to the second power times R2 4 kiloohms. This is equal 100 milliwatts. Okay, so this is the power at resistor R2. Next, we're supposed to find P3. P3 is equal I3 raised to the second power times R3, which is equal 5 milliamps raised to the second power times 6 kiloohms. This is equal 150 milliwatts. Okay, so this is the power at resistor R3. Next, we are going to verify if our answers are correct by adding these three powers together. So if P total is equal P1 plus P2 plus P3. Okay, if you are going to add all of them together, you're supposed to obtain 417 milliwatts. 417 milliwatts. So if you are going to compare this value with the total power over here, so you can see that both of them are very close to each other. So it means that our calculations are correct and the problem is solved.